Okay, let's work on recitation 7. So we need to solve and graph this polynomial inequality. Let's see 8. We see every term, we have 3 terms, trinomial is negative. So why don't we divide or multiply by -1 on both sides? So if we do that, multiply -1 on both sides. We got a positive x squared plus 8x plus 15. And then because we multiply by a negative number, we have to switch this sign because the negative means a negation. Now this one can be factored. But think about the factors of 15. 3 and 5. That adds up to be 8. Right? It can be factored like this. So now because this is greater than or equal to, so we have 2 scenarios. Both positive times positive, or negative times negative, positive, right? So let's see the first case. X plus 3 greater than or equal to 0, x plus 5 greater than or equal to 0. So the first one give us x greater, so we subtract 3 on both sides. Then this one subtract 5 on both sides, right? So let's graph this. Let's see, 0 is here, -3 here, -5 here. So x is greater than or equal to -3. We're starting from -3, greater than, go to the right. Greater than 5, greater than, go to the right. So we need to look for the intersection. Let me change my color for the intersection. So because the solution has to be for both of them, we see starting from here, right? This is the intersection of those 2 solution sets. So that means this one. So the first solution is this one. The second case, both negative. Actually, we don't really have to solve it, right? You can see from here, let me change my color to be green. Because it's basically the same thing, just less than or equal to. So less than or equal to 3, we go to the left. Less than or equal to -5, go to the left. Let me also use red color, maybe this pink color for the intersection. What's the intersection? Intersection starts from here, right? It's all this. So which means x less than or equal to -5 for the second one. So we have 2 solution sets. If we want to use interval notation, that's from negative infinity up to -5, including -5, union, including -3, up to positive infinity. So that's the first solution. Now let's see B. B, maybe you simplify a little bit. Let's use blue color first. So we have x raised by 4. Then this will have 5x cubed. So we move to the other side, negative 5x cubed. Then minus x squared. Then 5 times -x, -5x. Move to the other side, become plus 5x greater than 0, right? We have 4 terms. So 4 terms we want to put in a factor form. To group them 2 by 2. Out of those 2, we factor out x cubed. So x minus 5. Out of these 2, we have x factor out -x. So x also x minus 5. Because this one is a positive term, right? Negative times negative, positive, greater than 0. Now we have a common factor of x minus 5. So we factor out x minus 5. Then the first term we left with x cubed. The second term we left with x greater than 0. Now this term can be factored, right? This can be factored as x times x squared minus 1. Well, x squared minus 1 also can be factored. So let's write x up front. So we have x minus 1. X squared minus 1 is x minus 1, x plus 1, right? So we have x plus 1 and x minus 5 greater than 0. Okay, 1, 2, 3, 4. We have 4 factors. So what do? We could do just like A, but there's an easier way to do this. We just draw a line. We write down those numbers. So let's see, 0, because we have -1, +1, then +5, because we're thinking each one to be 0. So let's write 0 here, maybe 5 here, 1 is here, -1 is here, right? So this one, 0, 1, -1, 5. So I have those 4. So basically these 4 factors split into 4 intervals. So I have this interval up to -infinity, from -infinity up to -1, then from -1 up to 1, then from 1 up to 5, then from 5 up to +infinity. So what do? We're gonna pick a value to check. So this is -1, maybe this is -2. Okay, let's just pick -1 to check. Oh, also this is to 0, this is to 0. So in this interval, if we can pick -2 to evaluate. So x is -2. We don't really have to write down the number. We could just write down the sign. So negative, which means, let me use red color. So x is -2, negative sign. X is -2, -2 minus 1, negative sign. X minus 2 plus 1, negative. -2 minus, right? So all negative. So we have 4 -1s basically that become positive. So that means this interval is a solution. So from -infinity up to -1 is in the solution. Right. Now we have to consider from -1 up to 0. Well, let's pick a -half from here to evaluate. So -half, the first one is negative, -half minus 1 negative, -half plus 1 positive, -1 minus 5 negative, 3 negative, 1 positive, no. So this is not in the solution set. Now let's try the next interval from 0 to 1. Or maybe pick a positive half. So positive half, x positive, half minus 1 negative, half plus 1 positive, half minus 5 negative. 2 negatives, right? That's positive. So this is in the solution. So let's uni from 0 up to 1. Now let's pick a value from here. Maybe we'll pick 2 from the interval of 1 up to 5. Well, 2, x is positive, 2 minus 1 positive, 2 plus 1 positive, 2 minus 5 negative. So I have a 3 positive, 1 negative, so it's a negative. So this is not in the solution set. Now let's pick maybe 6, the last interval. 6 positive, 6 minus 1 positive, 6 plus 1 positive, 6 minus 5 also positive. Yes, in the solution. So we're using 5 up to infinity. All right, so I have a union of 3 sets. So let's just think about what did we do. So this is quite complicated. First, we move every term to left-hand side. We leave 0 on the right-hand side. Then we factor the expression, the polynomial, into factored form. Once we have this factored form, we focus on the number. So x, we think about, so basically we think about the equation. So if x is 0, so 0, mark 0 on the real number line. X minus 1 equals 0, mark 1 on the number line. X plus 1 is 0, -1, so mark -1. X minus 5 is 0, so mark 5. Then how many numbers? 4 numbers. 4 numbers split the real number line into 5 intervals. So then we can pick a value in each interval to see if it's, every factor is positive or negative. We don't have to evaluate the value. We just want to see the sign, positive or negative, because this is positive, right? So we check, so we pick a value from the first interval. The first interval is from -infinity up to -1. We pick -2. Then we see, yes, it's phase greater than 0. So it's in the solution set. Then we pick -half from the interval of -1 to 0, and it's not in the solution set. Also from 0 to 1, half not in the solution set. Oh, 0 to 1, it is half positive in the solution set. But from 1 to 5, not in the solution set. From 5 to 6, in the solution set. So we just uni all those in the solution set. Okay, let's see question 2. We want to solve and graph these rational inequalities. So it's not polynomial, it's rational inequalities. So this one, we have numerator and denominator. So this one is greater than 0. So when it's a quotient, we also have two cases, right? If the numerator is positive, the denominator is positive, then the sign is positive. Or if the numerator is negative, the denominator is negative, negative divided by negative is also positive. So we also divide into two scenarios. The first one is the numerator is positive and the denominator is positive. Then the second one is x minus 4, x plus 4, right? Difference of 2 squared being positive. And we also can do the number line, right? So mark -4 here. We mark a +4 here. Because out of this, we get a +4. Out of this, we get -4. Then we pick a value from those intervals. We'll have this interval, we'll have this interval, we'll have this interval. 3 intervals. So maybe you pick -5. Right? -5 is in this interval. Then maybe you pick 0 from this interval. Then maybe you pick a +5 from this interval. Okay, let's say -5. -5, the first one is negative. -5, second one is negative. Negative times negative, negative, positive. So this is in the solution set. So we write from -infinity up to -5. Then we try from -4 to 0. Maybe let's try -1. So if -1 minus 4, negative. -1 plus 4, positive. So no. So this is not in the solution set. Then we try 5. 5 minus 4, positive. 5 plus 4, positive. Yes, this is also in the solution set. So union from 5 up to positive infinity. But then we have to consider first condition. First condition is x has to be positive. So then negates this. So the solution for the first one is 5 up to positive infinity. The second one is both being negative, right? X is negative and x minus 4 times x plus 4 being negative. We could see we can use this one again. We use this one again. Well, this one is positive, this one is positive. So the solution, let me change my color. The solution just from 4 up to -4 up to 4, right? But then x has to be less than 0. So that means our solution is from -4 up to 0, right? Because x has to be less than 0. Now let's see b. b is greater than or equal to -3. Well, maybe we want to move -3 to the other side, then do some combination. So have x minus 7 minus or divided by x plus 5. We want to make a common denominator. So have -3 move to the other side, become plus, right? Plus 3 times x plus 5. And this is greater than or equal to 0. So 3x plus x, that's 4x. 7, 3 times 5, 15. 15 minus 7, that's 8. divided by x plus 5. That has to be greater than or equal to 0. Well, again, two cases, right? So 4x plus a greater than or equal to 0. X plus 5, both being positive, right? Or second one is both being negative. 4x minus a less than or equal to 0. And x plus 5 less than 0. Well, denominator cannot have equal sign, right? This has to be greater than 0 or only less than 0, no equal sign. Because it's a denominator. Now let's see the first one. So simplify this, divided by 4 on both sides. So we have x greater than or equal to -2. Move positive a to the other side becomes negative a divided by 4, that's -2. And this one is x greater than -5. Right. So we have -2. Let's see, this is -2, this is -5. 0 somewhere, right? We can do the same thing as we can do the same thing with pick. We can solve from like, because this is a simpler, this only have two scenarios. Maybe we can think, okay, this one saying x greater than or equal to -2. That's this one, right? Then this saying x greater than or equal to -5. Well, the intersection we know is this. So that's the first one. Well, when it's less than, that's just x less than or equal to -2 and x less than -5. That goes the other way around. And we see the intersection just x less than 5. So we use interval notation. We see -infinity up to -5, union -2 up to positive infinity. Let's see 3, logarithmic. We want to evaluate. So let's evaluate this. So let's see this equals to x. We rewrite this equation as 3 raised by x equals to 81. Well, what is 81? 81 is 3 raised by 4, right? Because we want both sides have the same base. Now, indeed, we have same base. If you have same base, we'll have the same exponent, so x equal to 4. Let's see b. B, let's say this equals to x. That means 3 raised by x equals to 3 raised by 8. That means x equals to 8. This one, let's say this equals to x. That means 3 raised by x equals to 1/9. Well, 1/9 is 9 raised by -1, right? Or is 3 raised by -2. So that's x equals to -2. Well, let's say this equals to x. And 3 raised by x equals to 1/3, 8 raised by 8. Well, that's 3 raised by -8. So x equals to -8. Let's see e. That's supposed to be x. So 3 raised by x equals to 1/√3. Remember, square root of 3 is 3 raised by half. Because it's in a denominator, so it's 3 raised by -half. So x equals to -half. Now let's see, this one equals to x. 3 raised by x equals to 3 raised by the power. We want to write as a rational exponents divided by the index. So that means x equals to m divided by n. Let's see, 4. 4, we want to expand those, each one of them. Okay, let's do this 3 first. When it's multiplication inside the log, that can be split as log base 2 of x squared plus log base 2 y squared. Then we can move the exponent in front of the log. So this can be written as 2 log base 2 of x. And we want to force x to be positive because the domain of log is positive number. Plus 2 log base 2. We want to force y to be positive as well. Because it's a square, right? Square changes negative to be positive. And this one is already addition, so we cannot do anything with this. So this is a prime expression. Let's see this one. This one in the numerator, so we just read out log base 7. Well, 3 exponents can go up front. X minus 2. That's numerator. Then in the denominator indicates a negative sign. And also this 2 goes up front. Minus 2 log base 7. Well, again, because this is 2, because this is even number, even exponent, I want to put an absolute value sign around it to force this to be positive. Same thing. This one I don't have to, because this is cube, raised by an odd number, so I don't have to force anything. If this is raised by odd number, this has to be in a positive number. Then I have z term, z to the 5 is also in the denominator, so still negative. Minus log base 7 of z to the 5, 5, and go to the front. So this is expanded, right? So basically the 2 rules. If it's in the numerator, that's positive term. If it in the denominator, that's negative term. The exponents goes up front to the logs. Okay, last 2 questions. Let's see, D log without base, that's base 10, right? We don't have to write it. So the numerator, we see this one has square, but this one doesn't. So if we simplify this one, right? We would have x raised by 2, x minus 2 raised by half. But then this is 2 times half. 2 times half is 1. So this one just is 3x plus 4. So that means this can be split as log base x minus 2 plus log base 10 3x plus 4. Right? The square cancel with a half. Then we have denominator, we have 2 terms. Minus log base x plus 7 minus log base 10 of x minus 5. Okay, so change with these 4 terms. Lastly, we want to rewrite this as a single one. So we have 1, 2, 3. Okay. So half means square root. This 3 goes to this 3, goes to the exponent. Right. So now addition, because this by default is positive. Positive means in the numerator. Negative means in the denominator. So we can write this as, well, all log 5, right? We just have to write it once, log base 5. The numerator is, we have x squared square root of x, because x raised by half, because this half goes to this exponent of x, that's just square root of x. Then in the denominator, we have x minus 2 raised by 3, then raised by 3 again. 3 times 3, that's raised by 9. And that's it. So that's recitation 7.